Samsung's next battery could reprice silver, not because it needs mountains of metal, but because a tiny materials choice, repeated at scale, can turn a quiet supply chain into a loud market. Most people hear that and immediately picture a fantasy, a silver battery, a single invention that drains vaults, a neat story that fits into a thumbnail. That is not what we are doing here. We are doing something harder and more useful. We are going to separate what Samsung has actually signaled about solid-state batteries from what the internet assumes. And then we are going to run the only test that matters in commodities. The mass balance test. How much silver could this plausibly use in the real world under real manufacturing incentives at real scale? And by the end, you will have three things. A clean story you can repeat without embarrassing yourself. A realistic range for how silver demand could change if this technology spreads. And a simple set of dials that tell you whether the battery story is becoming a real demand shock or just another viral moment. If that is what you came for, do me a favor right now. Subscribe. Because this channel is built for long-form investigations like this, where we do the math, we do the incentives, and we do not panic. And if you know someone who keeps sending you silver hype posts, share this with a friend, because this will save them from the kind of confident wrongness that costs real money. Now, let's open with a scene. A lab that is too clean to feel real, white light, quiet machines, technicians moving like they are handling something fragile and expensive. There is no shouting, no ticker-tappy, no price chart on the wall, just a material problem being solved one layer at a time. Then cut to the other world. A trading screen. Candles ripping up and down. Comment sections filled with certainty. People arguing about shortages and manipulation and secret meetings. These two worlds always collide eventually. The lab world moves slowly, but when it moves, it changes what the market has to believe. The trading world moves fast, but it often moves on, stories before reality arrives. The question is whether this story belongs to the lab world or the comment world. So what is the story? The story is that Samsung's solid-state battery roadmap is approaching the stage where pilot work becomes pre-production, and pre-production becomes commercialization. And running alongside that, there is a specific idea in battery research that keeps appearing in conversations. A silver-carbon composite layer, or a thin silver-containing component used to improve certain behaviors inside advanced cells. The internet stitched those two ideas together and produced a conclusion that sounds inevitable. If next-generation batteries use silver, silver demand is about to explode. That conclusion might be directionally correct, or it might be a mirage. The only way to know is to slow down and ask the most boring, powerful question in materials economics. If silver is used, how much per unit? Because everything changes depending on whether we are talking about a whisper of silver, a sprinkle of silver, or a serious slab of silver. And here is the first principle you need to tattoo on your brain for the rest of your investing life. Battery manufacturing is costed to the gram, sometimes to fractions of a gram. Every layer fights for its existence. No one adds an expensive material at scale unless it earns its keep in yield, performance, safety, or manufacturability. So if silver is inside a future battery, it will be there for a reason that justifies the cost. And that cost pressure will also cap the amount, which means the real story is not that silver will be used. The real story is how little silver can do something valuable, and what happens when you multiply that little by a lot. That is where commodities get dangerous. Not from one big bite, from a million small bites. Now, before we touch the hype, we anchor ourselves in reality. Solid-state batteries are not a single product. They are a direction, a family of approaches trying to replace or redesign parts of conventional lithium-ion systems, often to improve safety, energy density, and performance. Some of those approaches are closer than others. Some are easier to manufacture than others. Some are beautiful in a lab and brutal in a factory. And that brutal gap is where timelines get missed, costs rise, and grand narratives die quietly. So when you hear a company talking about solid state, you should immediately think in phase. There is the demonstration phase where a concept works at small scale. There is the pilot phase where you try to produce it repeatedly. There is the yield phase where you discover what breaks when you try to do it at volume. And there is the commercialization phase, where the problem is no longer whether it works, but whether it can be made cheaply, consistently, and safely enough to ship millions of units. Samsung has been one of the names associated with this direction for a long time, with public signals that point toward a pilot and a commercialization target in the later part of this decade. That matters because a corporate timeline, even if it slips, tells you something about intent and spending. It tells you this is not just a university paper. It is an industrial effort. But intent does not tell you materials, content. So now we shift to the silver layer idea. In advanced battery research, silver shows up in a very specific way, not as a giant chunk, but as a helper. A layer, a composite, a conductive component, sometimes discussed as part of managing how lithium behaves, how current moves, how interfaces stabilize, how plating and stripping behave, how dendrites are suppressed, how defects are tolerated. You do not need to memorize chemistry to understand the logic. The logic is simple. If you can improve a fragile interface with a better conductor or stabilize a difficult process with a clever composite, you can get performance that the market will pay for. And silver is an extraordinary conductor, which is why it appears in research. But here's the second principle you need tattooed next to the first one. Appears in research does not mean appears in mass production. Research is allowed to be expensive. A factory is not. Research is allowed to be delicate. A factory is not. Research is allowed to be slow. A factory is not. So the core mystery is not whether silver can help in a cell. The core mystery is whether it can help enough at low enough loading with high enough yield that an industrial player keeps it in the recipe. Now, the internet did what the internet always does. It took the most emotionally satisfying version and ran with it. It implied that batteries will start eating silver by the Some people even talk in a way that suggests each electric vehicle could contain a dramatic amount of silver. And if you are not careful, that story will hijack your brain because your brain loves a single catalyst. One invention, one shock, one clean villain or hero. But reality is messier, so we are going to do the mass balance test using nothing more than geometry and incentives. Here is the simplest way to think about silver inside a battery. If silver is used as a thin layer, the mass depends on a few basic factors. How large the area is, how thick the layer is, how dense the material is, and how many layers or components use it. That's it. Everything else is commentary. So when you hear someone claim enormous silver demand, what they are really claiming is that one of those variables is enormous. Either the layer is thick, or the area is huge, or it repeats many times, or all of the above. Now let's bound reality without pretending we have secret documents. Start with thickness. If the silver component is an inner layer, the economic incentive is to keep it extremely thin, thin enough to do the job, and no thicker, because thickness is cost. If it is extremely thin, the mass per cell can be tiny. Now multiply by cells per packs per cars per year, and suddenly tiny becomes meaningful. That is the most plausible path for a silver demand story. Not giant silver content per unit, but small silver content multiplied by enormous adoption scale. Now consider the other path, the viral path. The viral path implies silver content that is large enough to be obvious in bill of materials. The problem with that path is simple. Batteries are already expensive. Battery makers fight pennies, automakers fight pennies. A large silver loading would be attacked immediately by every procurement team on Earth. So if someone is claiming huge silver per vehicle, the right question is not, is it exciting? The right question is, why would a manufacturer accept that cost when alternative conductive materials exist, when designs can be optimized, and when recycling will be planned into the supply chain? In other words, the viral claim has to fight the most powerful force in manufacturing cost pressure. Now let's talk about scale, because scale is where this story becomes real, even if the silver content is small. Technology adoption rarely starts with mass market. It starts with premium tiers. It starts where cost is tolerated for performance. It starts with limited runs. It starts with flagship models. That means even if solid-state batteries begin arriving in the later part of this decade, early volumes might be low, so the immediate effect might not be a visible demand shock. But markets do not wait for volume. Markets anticipate, markets price option, markets react to confirmation, and confirmation can arrive before mass production. Confirmation looks like contracts, confirmation looks like CAPEX, confirmation looks like supply agreements, confirmation looks like a credible signal that a materials choice has been locked into a production architecture. Once that happens, the market starts asking the next question. Can the supply chain deliver? This is where silver becomes interesting again, because silver is not just a number on a screen. Silver is a real supply chain with its own frictions. You cannot instantly increase silver mining output without time. You cannot instantly increase refining and fabrication capacity without planning. You cannot instantly reroute industrial demand without dislocation. So even a moderate incremental demand story can create a premium. Not because the world is running out of silver, but because the world is running out of deliverable silver at the margin. Deliverable now, deliverable in the right form, deliverable into industrial channels, not just investor products. And when industrial buyers start paying up for certainty, the tone of the whole market changes. Now, we need to say something that will annoy both sides, which means it is probably honest. This battery story could be real and still be exaggerated. It could be real in the sense that silver demand increases at the margin. It could be exaggerated in the sense that the grams per unit are far smaller than viral posts imply. Both can be true, and the market does not care whether the internet was wrong about the magnitude. The market cares whether the incremental demand is enough to change pricing power in the physical chain. Now I want you to feel the real tension, because this is where the episode earns its time. The tension is not whether silver is used. The tension is whether the use becomes standardized. A one-off laboratory layer is nothing. A standardized manufacturing layer is everything, because standardization means procurement schedules. Standardization means contracts. Standardization means factories planning demand years ahead. Standardization means supply chains locking in. And once supply chains lock in, it becomes much harder for the market to dismiss the demand as theoretical. So now we set up the two competing narratives and we treat them fairly. The bull narrative says the world is moving into an era where industrial silver demand expands beyond the familiar drivers. If batteries add even a small new layer of demand, and that demand is sticky, the market gains a new structural bid. In that world, silver becomes less of a trade and more of a strategic material with a rising risk premium. The bear narrative says solid state is harder than people think. Timelines slip. Yield problems persist. Alternative designs reduce silver content or remove it entirely. Even if silver appears in some designs, cost pressure pushes it out. In that world, the battery silver story becomes another example of research hype that never becomes bill of materials reality. Both narratives are plausible, so we do not choose with emotion. We choose with a test. And the test is not one headline. The test is whether the story produces consistent, measurable signals in the real economy. Now, before we go to those signals, do me a quick favor. If you've made it this far, you are the kind of viewer who likes the full investigation, not the clip. Hit like, because it tells the algorithm this is not background noise. And share it with one friend who needs calmer analysis, because this topic is going to get loud. Now, the first signal is commercialization credibility, not vibes. Credibility that looks like repeated corporate confirmations, visible investment, and the kind of customer relationships that imply this is being built for real products, not for a slide deck. The second signal is materials disclosure, even partial, credible hints from technical documentation, manufacturing partners, or supply chain chatter that point to what materials are actually being used at scale. The third signal is procurement behavior. When big industrial players start securing long-term supply, the physical market starts to feel it. The fourth signal is physical tightness. Persistent premiums, tighter terms, longer lead times, and dislocations that do not quickly close. The fifth signal is substitution pressure. If silver demand begins rising, you should also expect engineers to fight back by reducing silver intensity, using alternatives, redesigning layers, and planning recycling. That is not a reason this story is false. That is what a real story triggers. Now, let's bring it back to the simple truths. This is not a story about a silver battery that drains the world overnight. This is a story about a thin layer, repeated at scale, colliding with a supply chain that is not infinitely elastic. And when that collision happens, the market response is rarely smooth. It comes in waves. First, the idea spreads. Then, early confirmation appears. Then, money flows into the narrative. Then, the market Then, reality checks it through yield, timelines, and cost. Then, if the foundation is real, the story returns stronger because the supply chain has begun locking in. That is the pattern you should expect if this is real. And now we arrive at the part you deserve most, because it is the part that turns this episode from interesting to useful. We are going to do the bounding. We are going to stop talking in slogans and start talking in ranges. We will not pretend to know exact grams, but we can define what must be true for extreme claims to be true. For an extreme silver demand claim to be true, the silver-containing component would have to be thick enough and widespread enough across the cell architecture that it becomes a major cost input. That would mean battery makers accept a recurring premium material at scale. That would mean automakers accept it in mass models. That would mean engineers fail to reduce it through design. That would mean alternatives fail. That would mean recycling cannot meaningfully offset it. That is a lot of conditions. For a moderate demand story to be true, we need much less. We need silver to be used thinly, in a way that meaningfully improves performance, and we need adoption to reach a scale where even small mass per unit becomes meaningful. We need procurement to treat it as a necessary input. We need the supply chain to feel that incremental pull in deliverable forms. That is fewer conditions, which is why the moderate story is the one you should treat as most plausible until proven otherwise. And if the moderate story is true, then the biggest moves in silver may not come from the first pilot cells. They may come from the moment the market realizes that small grams times massive scale equals a new structural bid, because that is when industrial buyers and investors start competing for the same marginal ounces. And in silver, the margin is where price lives. Now, we finished the job and turned that idea into something you can actually use, because right now you have attention in your hands. A thin layer, repeated at scale, could matter. But not every thin layer becomes a standard. Not every standard becomes mass adoption, and not every adoption creates a lasting demand shock. The market is full of technologies that looked inevitable until manufacturing reality hit them in the face. So we are going to walk through the real decision chain that determines whether silver demand actually changes. And we are going to do it in the most honest way possible, by putting ourselves inside the incentives of the people who would have to sign off on silver being used in a battery at scale. Start with the battery engineer. The engineer does not care about your silver thesis. The engineer cares about performance, safety, longevity, and yield. Yield is everything. Yield is the percentage of units that come out of the factory meeting spec. If yield is low, a battery can be brilliant and still be dead. because no one will pay for the waste in the rework. So if a silver-containing layer improves yield, improves interface stability, improves safety margins, or improves cycle life enough, it becomes hard to remove. It becomes the kind of material choice that survives cost pressure because it makes the factory run. Now move to procurement. Procurement cares about cost, supply security, and contract structure. Procurement will ask a simple question. If we include this material, can we buy it reliably for years across multiple suppliers without getting cornered on price? Procurement is allergic to single points of failure. If a material introduces a new bottleneck, procurement will push back hard. They will ask for alternatives. They will ask engineers to reduce loading. They will ask for second sources. They will ask for recycling plans. They will ask for long-term off. If silver demand is going to rise because of batteries, it will rise first because procurement starts securing it quietly before the public understands why. Now move to the automaker. The automaker cares about cost per vehicle, but also cares about differentiation. In early adoption, an automaker may accept higher costs for higher performance in premium models. That is how new technologies enter. They enter where cost is tolerated, but premium models do not change global demand by themselves. They change narrative. The real demand change comes later, when the technology moves down the cost curve and into broader models, or when it becomes so superior that it becomes the standard. So the question is not whether a lab layer works. The question is whether it becomes a procurement line item that scales. Now we bring it back to silver. Silver has one advantage. It keeps pulling it into advanced designs. It is incredibly conductive. It can solve certain interface problems elegantly. Silver has one disadvantage that keeps pushing it out. It is expensive compared to other conductive materials, and it is watched by markets that can turn it into a volatile input. So if silver remains in the design, you should expect one consistent pattern. Engineers will fight to minimize it. They will make it thinner. They will confine it to smaller areas. They will use it only where it does the most work. They will combine it with other materials, so the silver content is low, but the effect is high. That is why the most realistic silver demand story is not a battery full of silver. It is a battery with a silver touch, a thin, optimized touch that survives because it enables something valuable. And that is why the mass balance test matters so much. Because the difference between a silver touch and a silver slab is the difference between a minor demand tailwind and a disruptive demand shock. So let us bound it the right way, without pretending we have secret grams. Imagine 3 worlds. In the first world, silver is used as an extremely thin interlayer in a limited part of the cell, designed to stabilize an interface or improve plating behavior. In that world, this silver per cell is small. You would not call it a silver battery. You would call it a battery that uses a small amount of silver as an enabling material. The demand impact in that world depends almost entirely on scale and adoption speed. It starts as a whisper. It becomes meaningful only if production reaches millions of units and stays there. In the second world, silver is used more broadly, perhaps in multiple layers or over larger areas, still thin, but repeated. In that world, the silver per cell could move from small to moderate. Now procurement starts caring more intensely because the cost and supply security matter. This world could create real demand pressure if the technology becomes common. But it also invites aggressive design optimization because moderate silver loading is a tempting target for cost reduction. In the third world, the viral world, silver is used in a way that makes it a major bill of materials item. In that world, each unit contains a large and obvious amount. This world would create an explosive demand story if it were real. But it has to fight manufacturing reality. It has to fight cost. It has to fight substitution. It has to fight recycling. It has to fight the simple fact that battery makers and automakers do not voluntarily install volatile precious metal exposure into the heart of mass production, unless there is no alternative. This is why extreme claims should not be your base case. They require too many things to go right and too many other things to fail. Now, here is the twist that makes the story interesting again. Even the first world can matter, because silver is not a market that needs enormous new demand to feel tight. It needs marginal demand that arrives when the market is already sensitive. It needs new demand that is sticky, that cannot easily be turned off, because it is embedded in the supply chain. A new demand driver that is small but inelastic can change how the market behaves. Inelastic means the buyer cannot easily reduce demand without redesigning a product. If a layer is essential, the buyer pays. That is how a small gram story becomes a pricing story, not through size alone, but through stickiness. So what decides stickiness? Stickiness comes from standardization. Once a manufacturing architecture is standardized, changing it is slow and expensive. It requires validation. It requires new safety testing. It requires new supply chain qualification. It requires new yield learning. That is why standardized materials choices tend to persist for longer than outsiders expect. So the key is not whether a research paper mentions silver. The key is whether a production design locks silver into a standardized layer. If that happens, then the market does not need to guess. It will see the effects through procurement behavior. Now, we talk about the timing, because timing is where people get fooled. If you are expecting an immediate demand shock, you are likely to be wrong. even if the story is ultimately real. Technology adoption takes time. Pilot phases take time. Yield problems take time. Scaling factories takes time. And early runs tend to be small, so the near-term impact may be mostly narrative. It may be investors moving on anticipation. That anticipation can still move price, because silver is sensitive to flows, but anticipation is fragile. It can reverse quickly. The durable impact arrives when the supply chain begins to lock in. That is when procurement starts contracting. That is when manufacturing partners start building capacity. That is when a material choice becomes a forecast, not a possibility. Now we confront the hardest part for the viewer, the part that requires intellectual discipline. If the market starts running on this story, it will likely overshoot, because that is what markets do. They price the best case before reality has proven it. They buy optionality, and then they punish anyone who confuses optionality with certainty. So if you are thinking about this as an investor, the most important lesson is not to chase the hottest version of the story. The hottest version will be priced first and punished first. The smarter approach is to watch the dials that reveal whether the story is moving from lab to factory. Here are those dials in plain language. The first dial is commercialization confirmation. Not a single press mention. A pattern, continued signals that a pilot is advancing, that investment is continuing, that manufacturing plans are being built, that customers are engaged. The exact details can be subtle, but the pattern is what matters. Real commercialization leaves footprints because money must be spent and relationships must be formed. The second dial is materials reality. Does credible technical information begin converging on a specific architecture? Do we see consistent hints that certain layers or composites are being used? And more importantly, do we see any indication of how heavy or how light the material loading might be? You do not need perfect numbers. You need the direction. Is this a trace layer, a thin standard layer, or a broad heavy input? The market's reaction should depend on that answer. The third dial is physical tightness. This is the most honest dial in commodities. It is hard to fake for long. If incremental industrial demand begins to bite, it shows up in the cost of immediate persistent premiums, longer lead times, tighter terms, a stubborn sense that getting metal now costs more than it used to. This is where a real demand shift announces itself even before the spot chart fully reflects it. Now, because you are not watching this channel to hear only the bull case, we give the counter case the respect it deserves. The counter case begins with a single brutal fact. Solid-state batteries are difficult. Interfaces are difficult. Scaling is difficult. Yield is difficult. Many brilliant battery ideas die between the lab and the factory because the factory is the ultimate judge, and the factory judges by cost and repeatability, not by... The counter case says the timeline slips. It says performance is hard to maintain at scale. It says defects become a nightmare. It says manufacturing equipment becomes expensive. It says the final product ends up using different materials than early research discussed, because the factory forces... The counter case also says even if silver is used initially, it becomes a target. Engineers optimize it down. Procurement pressures, alternatives. Recycling is built into the plan. Supply contracts reduce spot volatility exposure. In the counter case, the story is real enough to be true, but not large enough to be a silver market revolution. And that is why you do not decide this story with belief. You decide it with observation. Now we do the synthesis that brings the whole episode into one clean mental picture. Imagine a single thin layer that improves a battery's behavior. It might be a tiny part of the cell, but it solves a hard problem. Because it solves a hard problem, it survives the pilot. Because it survives the pilot, it enters a premium product. Because it enters a premium product, it gains credibility. Because it gains credibility, procurement starts securing supply. Because procurement starts securing supply, the physical market begins feeling an incremental pull. Because the physical market begins feeling it, premiums rise. Because premiums rise, the paper market notices. Because the paper market notices, the price runs. Because the price runs, engineers redouble their effort to reduce silver intensity. Because engineers reduce intensity, the demand shock is capped. But because the architecture is standardized, the demand becomes sticky even at lower intensity. That is the realistic path. Not a single explosion, but a long tightening of optionality. Not a silver apocalypse, but a rising strategic premium. And in markets, a rising strategic premium is enough. Now we close with the final lesson, the one that keeps you from being played by the loudest post. This story is not about whether Samsung uses silver. This story is about whether the battery industry adds a new category of silver demand that is industrial, repeatable, and sticky. If it does, silver becomes less dependent on short-term sentiment and more anchored by procurement behavior. If it does not, silver remains a market driven mostly by the familiar forces, macro narratives, investor flows, and existing industrial demand. Either way, the only safe approach is to watch behavior. Watch whether the world begins paying more for silver now, not later. Watch whether physical tightness becomes persistent. Watch whether credible commercialization signals keep stacking. Watch whether materials reality points to a standardized architecture. Because when those signals align, the market will not wait for perfect proof. It will move, and it will move the way silver always moves when a news story becomes believable. Late, and then fast. If you got value from this investigation, subscribe so you do not miss the next episode. Because we are building a full series on the silver supply chain, the real drivers, and the signals that matter more than noise. And send this to one friend who keeps falling for viral commodity math, because the best edge you can have is not being first. It is being right about the mechanism. A thin layer can be enough not to drain the world, but to change the price of and when the price of immediacy changes, silver stops behaving like a simple chart and starts behaving like a constrained system. That is when the market rewrites the story for you, whether you are ready or not.